What if I told you the universe once expanded faster than light itself? And no, Einstein wasn't wrong. This is one of the most mind-bending discoveries in modern cosmology. Let's start with what cosmic inflation actually is. In the very first moments after the Big Bang, something extraordinary happened. For a tiny fraction of a second, we're talking about 10 to 1032 seconds, the universe underwent an exponential expansion that made it grow by a factor of at least 1026. That's a 1 with 26 zeros after it. Now here's where it gets really interesting. According to Einstein's theory of relativity, nothing can travel faster than light through space. But cosmic inflation wasn't about objects moving through space. It was about space itself expanding. And there's no speed limit on the expansion of space itself. Think of it like this. Imagine you're on a rubber sheet that's stretching. Even if you're standing still relative to the sheet, the distance between you and another point on the sheet can increase faster than light could travel across it. That's essentially what happened during inflation. So why did this happen? The leading theory involves something called a scalar field. Think of it as an energy field that filled the early universe. This field was in a high-energy state, and as it decayed to a lower energy state, it released tremendous energy that drove the rapid expansion. This wasn't a gentle growth. It was an explosive, exponential expansion that smoothed out the universe and set the stage for everything we see today. The evidence for cosmic inflation is actually written in the sky. The cosmic microwave background radiation, that faint glow left over from the Big Bang, shows an incredible uniformity across the entire observable universe. Regions that are now billions of light years apart have almost identical temperatures. But here's the problem. Without inflation, these regions would never have had time to communicate and reach the same temperature. This is known as the horizon problem. Inflation solves this by suggesting that these distant regions were once much closer together before the rapid expansion separated them. Another piece of evidence comes from the flatness of the universe. Measurements show that space is remarkably flat on large scales, which inflation naturally predicts by stretching any initial curvature to near-perfect flatness. There's also the fact that inflation explains why we see the large-scale structure of galaxies and galaxy clusters that we do. Tiny quantum fluctuations during inflation were stretched to cosmic scales, becoming the seeds for all the structure in the universe. Now, you might be wondering, if space expanded faster than light, does that mean we can never see what's beyond our observable universe? Exactly. The parts of the universe that were pushed beyond our cosmic horizon by inflation are forever inaccessible to us. They're moving away from us faster than light can reach us. This leads to the mind-boggling realization that what we can observe is just a tiny fraction of the entire universe. The implications of cosmic inflation are profound. It suggests that our universe might be just one bubble in a vast multiverse, with other universes having different physical laws. It also provides a natural explanation for why the universe looks the way it does, without needing special initial conditions. But cosmic inflation isn't without its critics. Some physicists point out that while inflation explains many observations beautifully, it's difficult to test directly. The energy scales involved are far beyond what we can recreate in particle accelerators. However, researchers are looking for indirect evidence, such as specific patterns in the cosmic microwave background or gravitational waves from the inflationary period. What's truly remarkable is that this entire cosmic drama played out in less than the blink of an eye. In that infinitesimal moment, the fate of our universe was sealed. The rapid expansion determined how matter would clump together, where galaxies would form, and ultimately made the universe hospitable for life as we know it. So the next time you look up at the night sky, remember that the vast cosmos we see is the result of a brief but spectacular period when the very fabric of reality expanded faster than light itself. What's the most mind-blowing thing you've learned about our universe? Drop your thoughts in the comments below.